Hello everybody, welcome to a new programming language video. Today I'm going to teach you data types in the C++ programming language. So data types are basically how you represent your data, and there are many different data types in the C++ programming language. We use data types because we want to represent multiple specific data or all kinds of data. We have decimal numbers, floats, ints, chars, doubles, arrays, buffers, and pretty much anything that comes with the C++ programming language or anything that comes with data types. You know, in many different languages, for example, like TypeScript, they have basic data types that are very important when it comes to representing data. So the key about data types are that in C++ is that we must, understand the data types in memory because this is a low-level programming language, which means C++ is very close to the hardware. There's no layer of abstraction between it. Um, there's no layer of abstraction between the hardware because you're so close to the hardware. You're so close to the CPU, you're so close to the RAM, so you pretty much have to understand how big your data types are in memory, or these data types will consume so much RAM. So let's go ahead and let me go ahead and stop talking and we can go ahead and get into the video. So I have a basic Hello World program, and this is really it. This is just a Hello World program. Let's say I'm creating an application and I want to go ahead and just create a couple of data types to represent pretty much any amount of data. It can be a name, it can be a number, whatever, but let's start with the first data type, which is char. And what is char? So a char is a single character. On the computer, it is represented as an ASCII character, and each character has an ASCII number associated with it. But that is like within the low level um, area. So C++, the good side of it is that if you understand the computer, then you can understand the types in memory as well. So for char, it represents a single character. So let's say I just wanted to work with single characters for some reason. So let's say I wanted to have the letter A, or I want to represent a grade. Let's say we have a grade, and then we could set this to any single character we want. And this is only single character. We cannot really put, well, I guess this is allowed, but we want to represent a single character, and that is char. Now, the thing is, the best part about C++ is that we can output the size of specific types in memory, so we can see how much bytes they take up. Now, the size of is a operator. It is a function simple operator in C++, and this allows us to get the size of a specific type, or pretty much anything else. Size of returns size t, which means size t represents any type on a computer, but they vary on different architectures and different computers. So for size t, this size of the unit for size t is bytes. Okay, so we're going to go ahead and represent our single character, but we're just going to have our grade here, and then I want to print the grade, so I'm going to also just output the grade, and I'm going to stop with the excess printing as well, because I've noticed that most of my videos are sometimes incorrect and wrong, so please always correct me if I'm wrong, go on other videos and watch those if you haven't seen them. But as you can see, I have our single character here, and this is 1, and then this is C. So this is pretty good because I can represent basically things with precision. I don't have to use a string. Now, C++ allows us to have all of these data types, and we can represent our data with precision. So char takes up 1 byte. Okay, well, let's say I want to do whole numbers now in our program. To represent a whole number, we would use an integer, and an integer is 4 bytes in memory. So this take up 4 bytes of RAM. So an int could represent any whole number. So let's say we have a score, and with that score, I create 20. And we can always, get the size of a score on our computer just by doing size of int. And then if I want to, then I can reassign this variable by just setting score to 90, or I can set score to whatever. But before I do anything, we can reassign these variables later. Just know that C++ allows that. So now if I run this, if I represent whole numbers, Now, as you can see, the size of score is 4. And again, I'm just going to print out score because just whatever. All right, so I'm going to run our program. And as you can see, we have basically everything here. And I'm gonna keep the size of here. I'm gonna do size of char. And then down here, I'm gonna also do size of int to do some little bit of cleaning up. And then I'm gonna rerun our program. And there you go. So as you can see, size of char is 1, size of int is 4 bytes, and we get whatever that's printed after. So our program is looking great. Now floats. Floats allow us to represent decimal numbers. Let's say I'm dealing with money here, so money values. So let's say I were to create a float, and this is going to be cost amount or whatever. And then for float, we could say 4.99. We must use the F keyword at the end to tell C++ that it represents a float. So this is basically the F keyword, and it is in Java as well. But I'd like to use the F keyword because it basically tells us that, hey, this is an actual float. So this is a floating point, and this allows us to represent decimals in our program, floating points. So yeah, that's float. Now, what I'm going to do is I'm just going to do the same thing, size of float, size of float. Now, floats are basically 4 bytes in memory. Floats are 4 bytes in memory, and that's really it. And then I'm going to do cost amount. And then there we go. So when we run this program, we have the size of float, which is 4 bytes in memory, and then we have our decimal number here. So there are multiple different things we can do with all of this so far, which we have learned, char, int, and float. And then we can also create struct members. Now, struct members, I would say yes, they are types as well, but these allow us to represent objects in memory which contain multiple different variables. So when you create a struct, the CPU basically has that data that's aligned all together. It's like all very close together. So I'll worry about structs at the end. But for now, let's continue off with what we are doing. So now double. So double is with precision. Basically, these are more bigger floats, basically the 64-bit float. And double is 8 bytes in memory. So double allows us to represent larger floating points, larger decimals, or just larger, even larger numbers. So for double, let's say I have a player health, and I'm just going to do 200, oh, that's really it. Now we're going to get the size of that. So we're going to get the size of double. And then we're also going to put the player health here. Perfect. So once again, double is 8 bytes in RAM, double is 8 bytes in memory, but I'm going to give you a warning because with this representation here, um, that I'm doing, basically on different computers, the sizes may be on different types. And for here, it's guaranteed that this is double, but on different computers, just letting you know that I'm giving you a little warning. Depending on your computer or system, then these sizes may change. Like in one case, an int could be 2 or 4 bytes. It just depends on the computer architecture. All right, so double, basically larger decimal numbers with precision. Perfect. So let's go ahead and create a Boolean. Now, a Boolean is basically 1 byte in memory, and it allows us to represent true or false. True or false is basically a term for logical conditioning. Let's say we are creating an if statement and we have a condition that's either true or false. If the condition is true, then the CPU will go to the code block or it will go to the condition where is the statement is true. Otherwise, if it is false, then it will ignore the statement and it will continue. I'm not really good at explaining it myself, but how would I explain it is Boolean is not really an expression, but it has something to do with logical operations. And for Boolean, it just represents either true or false. Let's say we have if 1 is greater than 5. That is false because 5 is greater than 1. So the program will execute the code. No, the program will go elsewhere. That's if there's an else statement. The program will ignore that statement. But if 1 is greater than 5, but which it will never be, so let's say like 5 is greater than 1, that is true, which means the program will continue to the area where it is true. So I'm not really good at explaining, and I apologize, but let's go ahead and create our Boolean. Now we're going to create is crouching, and the size of a Boolean on the system should be 1 byte in memory. So we're going to do size of bool. We're going to create size of bool. And then we're also going to print out our is crouching. Now I'm going to give you a little warning here because Booleans are actually represented in memory as 1 or 0. It's like 1 byte, so it's like a 1 byte, and then you can flip that byte 1 to 0, 1, 0 using bitwise operations. So as you can see here, we have our is crouching, and we have the size of bool 1, and then this is 1. Now, to get the string representation, we're going to use std bool alpha, and then we're going to run our program again. And as you can see, it now says true, and we also can reassign this to false. So just know that a Boolean can be either true or false, nothing really else. And then it represents 1 or 0 in memory. Perfect. So once more, let me clarify Boolean. For Boolean, we can go ahead and create logic within our programs, and this data could represent if something is true or if something is false. And then we can check that Boolean with logical operators to depend on what should the code do if the statement is either true or false. Awesome. So now the next type I have is string, and we must include the string library inside of C++ because this is a part of, I wouldn't say the standard library, but this is a part of the program language. We have to include string. And when we include string, yes, this is actually a part of the standard library. When we include string, we have to do something called std. And this allows us to access the functions that are in the standard library and types as well. And the type I am looking for is string. And this is actually a string. Now, a string in memory is different. String contains more bytes in memory. I'm not really good at the sizes, but it depends on the size of the string. Now, the string could be either allocated on the heap or the stack, but the strings are mainly heap allocated. Now, the only time a string is stack allocated if C++ or the compiler does something called the small string optimization, where if a string is small enough, it will put it on the stack. So let's say I have a name, and I'm going to call it Joey. And as you can see, that is a string. And then if I want to get the length, create a size t, and then I could do starlen. Starlen is different, so I'm actually going to do name.length. And then, before I do anything, this isn't really the size, this is the actual length of the string, but I'm going to do size of std string. I am also going to do mylen to output the length of the string, and then also I'm going to output the name. And just to make this more easier, I'm going to also put this string here, so Boolean value, and then I'm also going to print out the rest of the stuff here. So And then I'm also going to go ahead and grab the string. All right, awesome. So I understand that I said I was going to stop printing out all the excess stuff, but let me see. This should have a space. All right, so the size of string does not have a space, which makes it looks confusing. But as you can see, what? Give me a minute. Size of string 40. Lengths of string 4. That's 2 spaces. But as you can see, it's fine. Don't worry about it. As you can see, the size of string is 40 bytes in memory. The length of string is 4, and then the string is Joey. So that is when we want to represent text in our program. And to use a string, we have to write something at the top of our C++ file called include string. And then we can also use this here by using std string. Now, one thing I would not recommend personally is using namespace std because that dumps pretty much everything in here. And then another problem is if you include windows.h, that also just messes up with your autocomplete, in my personal opinion. But this is if we want to represent once again, the std string type allows us to represent text in our C++ programs. Okay, so let's go ahead and create arrays. Let's start with arrays. So we came so far, but I'm pretty much happy you guys stayed along with the way. And I'm very happy for all of you guys watching. Please correct me if I'm wrong in any videos, but let's go ahead and go with arrays in C++. And what are arrays? Arrays are basically packed data. They're all together in a list. And C++ allows you to just have arrays and they're lists. You can reassign the values that are in an array. You can access the array, and you can pretty much use pointer arithmetic with the array. So let's make arrays easy. So let's create an int array. So to create an int array, we have to first specify the type, int. And let's say we have a score list. I'm going to do it like this. And then here we must put brackets here because we must represent the size of the array. And then we can simply assign it like that. And this is our array in C++. Now, one thing that we could be doing is that the C++ compiler or the CPU that's in your computer right now sees this and says, oh, look, this is just arrays packed together. This is just scores packed together in memory. So what I'm going to do is I'm going to look at this array and I'm going to see 4 bytes apart, 4 bytes apart, 4 bytes apart, 4 bytes apart, 5 times until we are at the end. So basically, it's like somewhat a continuous block of memory. So let's go ahead and create our numbers. So let's say we have a first score of 100. Maybe you got a 75. Maybe you got a 75 on the next score. You got an 85, and maybe you got a 95. Maybe you failed. Uh, so those are 5 values. We can't really put any more values in there, and that's our basic array. Now, here is our array, and we use arrays so we can represent basically lists of data that we can reassign. So the first thing I can do with my array is get the first item that's in the list. And to do that, we have to type in the variable name and the number, and index arrays start at 0 in C++. So that is the first score here. So when we run this, we get 100. So that is the first score in here. And this is 0, 1, 2, 3, 4. So this is 0 through 4. If it's 5, this is 0 through 4. If I put 6 in here, that's 0 through 5, and so on and so forth. So index arrays start at 0. Let's say now I want to change this number that is in here from a 20 to, let's say, like a C, so like a 70. So to do that, we have to first have score list here. And we have to change the fourth element, which is the last element, to 70. Now we can go ahead and do the same thing by indexing the last item in this list. Now what happens is when we run this, as you can see, oh, this is actually bad because Now, I broke something. Now, I'm going to show you the problem of what I did. So there are 5 elements are in here. There are 5 elements in here, and it says that I'm probably going out of bounds because it says the readable size is 20 bytes, but 24 bytes may be read. So I'm reading out of bounds. So I have to change this to 4 because remember, index arrays start at 0. So be careful with that trap because you could access memory that you're not messing with and your program can crash. All right, there we go. So we changed it to 70. It is now representing 70. So arrays are pretty much easy in C++, but before we do anything else, I'm gonna remove this because I basically showed you how to reassign those variables. I showed you how to do the bare minimum with arrays, but I'm not really done yet. Let's say I want to loop through this array. Now, to do that, I'm gonna create a for loop called int I equals 0, and then we're gonna set our expression to the length of I. So I think I have to do size of score list divided by size of int I plus plus. We can't do this on the heap though. So if this was a heap allocated array, we cannot do this because I think it'll return, I think the int is like a address. I think the pointer, if you're doing the size of the pointer, it will return the size of a pointer, which is 8 bytes in a 64-bit system, which in my system is 64-bit, and that will give your program a crash. So the best way to loop through heap allocated arrays is manually track the size by creating another variable that is the size. So here we have the score list, and then we can put I in here, which is our counting variable. And when we run our program, we get 100 through 20. So that is how we can loop through an array as well and print the values. We can also set the values. We can do whatever we want, but that's really pretty much it with arrays. Now, one more thing, pointer arithmetic, my favorite. Pointer arithmetic is basically you using operations on a pointer to move to the next piece of block, move to the next move to the next address to get whatever value is in there or whatever. First of all, we need to understand pointers and arrays first. So let's say this is a stack allocated array, and I create a pointer called p score list. And what I need to do is I need to get the address of score list. And we forgot that this is here. So we have an integer that is p score list. Let's see. Oh, my bad. Is this? Hmm. Wait a minute. P list equals the address of score list. Am I supposed to specify a size? I'm not really. I haven't did this in a while. Oh, okay. Oh, wait. Hmm. All right. Well, that's fine. I couldn't do the pointer arithmetic, so let's do a Google search. There we go. So we weren't supposed to use a size or the ampersand, but we get it right here. Okay, so pointer arithmetic allows us to step through arrays and buffers as well, I think, and other things, but mainly arrays. And we can move forward and backward to the next element. So let's try this again. So PS list, actually P score list equals to score list. There we go. So we have our pointer to this element here. Now, one dangerous thing is since this is on the stack, then if this goes out of scope and we're using this pointer, then our program is just going to crash. That's really it. So we have our pointer called p score list, and what we're going to do is pscore list has the first element to that array there. So what we can do is we can dereference this pointer by doing pscore list, and that tells the CPU saying, hey, I want to know what's inside of this first pointer, what's inside of this first element. And it tells us that 100 is in there. Now let's say I want to move forward. I want to say pscore list plus plus. That is incrementing the pointer. Now we can dereference it again, pscore list, std line. And then when we run that, as you can see, now we move to 75. That is simple pointer arithmetic. Now that we can increment this, we can also decrement this. So let's say at one point I want to go back. I can do pscore list negative negative, and then simply do pscore list, and that takes us back to our last item, which is 20. Well, back to our last item, which is 100. So this is 75, 100, 75. So that really is pointer arithmetic. Allows us to increment and decrement through here, and this is the first item. And the thing is, you must know the size of here, because if you don't, then you can increment out of bounds, and that is also another crash. And so there are basically two types with two errors with this. The first thing is if this goes out of scope and you're using this pointer, then it's a crash. Or if you access out of bounds, that's also a crash. And then finally, the last one is if you increment all the way at the bottom, like if you increment past 4, which is our items from 0 through 4, which since index arrays start at 0, then that accesses as a crash. So if I increment this 5 times, this pointer is going to crash. So if I access it 5 times and dereference or try to reassign it, it will crash. So that's basically pointer arithmetic and the basics and the traps with pointer arithmetic. So that's really it. Pointer arithmetic is really cool, and I've used it myself before too when incrementing, decrementing pointers. And that's really it. All right, so now that's arrays basically. Now you can do you could do the same thing with almost any other type. If it's heap allocated, then that's different. Correct me if I'm wrong. But for heap allocations, since this is on a heap, you have to mainly track the size. And I'm going to show you, instead of heap allocated buffers, I mean heap allocated, yeah, heap allocated arrays. I meant arrays, not buffers. But buffers, I'm going to show you buffers. So yeah. All right. So let's go ahead and, you know what? I'm going to do buffers arrays. So, okay, wonderful. So perfect. All right, so we have the type aliases here, and I'm going to get into type aliases now. So we're pretty much done with most of the data types, but we have 3 more data types to go, and that will be the end of this video. So let's go ahead and first start off with type aliases. What are type aliases in C++? Type aliases are basically another way of renaming types. So basically, people can read your code and understand what you're representing in your program. So they can say, okay, so it looks like that this is the player ID. That's better. But it says that under the hood, this player ID, it's another name for this type, and this type is actually an integer on the background. So to create a type alias, you have to use the using keyword. And to do using, we can just do using. Now, we also have using and type def, but I'm going to do using. And for using, I'm just going to say using player ID. And let's say player ID was an integer. And as you can see, that is our first type alias. We can use this normally as possible. We can turn it into a pointer. We can turn it into a reference. It's just another name for the same type under the hood. And this is pretty much a very good practice, because that way people reading your code can understand that this is representing a player ID. It says, oh, okay, so this is a player ID and this is actually an int. So let's say I create a struct called person and it has a player ID called ID, and then it has an std string name. And this is a structure. It allows us to represent objects in memory. So in this structure, it contains a string and a player ID for that is type alias as an int. That's really it. So type aliases aren't really, I guess that's really it. There's really nothing else. It's just you're using, let's say, money equals float. So that's basically it. You're basically renaming one type as another. That is a type alias. And if you need help, I have some resources. We have CPP reference and learncpp.com. This may seem very hard to learn, but let's say like we want to find using or type alias or types. We can look it up. But the thing is, I love reading this, so we should find using. As you can see, we could use using, and this is under the hood. It's just a struct. So that's a new type. And then as you can see, he's using, well, they're not really using the struct here, but this is a way to use the using keyword. So well, it really isn't hard reading this, but there are two references here I use for C++. All right, so that's really it for a type alias, but let's get into buffers. And these are my favorite in C++. So let's go ahead and create a buffer of an object. And I'm looking at a float buffer. I want to do a float buffer that represents some memory. So let's do that. So to create a buffer in C++, you just do float. You'd create the type, and then you'd create the value. So let's say health buff. No, transaction transactions buffer, and I want to do 7 of these. Now, a buffer is continuous block of memory. A buffer is a continuous block of memory. Would you say it's the same as an array? That I don't know personally, but the difference between an array and a buffer is that the buffer is uninitialized until we actually used it. The array is an initialized as well. So array is initialized, the buffer is uninitialized. So we have 7 elements, we can go with the buffer. And to use the buffer, well, let's say first of all, I want to get the size of transactions buffer. Oops. It says transactions buffer. Actually, I'm going to do transactions buff, just so people know that it's a buffer. And then when we run our program, then this is basically 28 bytes. So basically, it's a continuous block of memory, and this buffer is allocated on the stack. Remember, if this buffer goes out of scope and we're using pointers and stuff like that to the internal data and stuff like that, then that pointer is going to be invalidated and our program is going to get a crash. If you go out of bounds to the buffer, then you're also going to get a crash. If you write more things to the buffer, if you write out of bounds, that is called a buffer overflow, and that is also going to cause a crash as well. So you must know the traps with buffers, and you must understand that if you're using pointers and stuff like that, I do recommend null checks, but I don't recommend pointers at the same time because you can also use references as well if you're referencing data, because references are guaranteed to exist. Pointers are liars, and they either may or may not exist. And also, a pointer specifies the absence of memory. So it could be there or it couldn't, or it could be there or could not be there. But you as the programmer, when you're using references or when you are using pointers, you must guarantee that the pointer exists so your code can continue with the flow. So as you can see, we said that a float is 4 bytes of memory. So what we did was when we create our buffer with 7 elements, it basically said, okay, so 7, okay, so what is 4 bytes times 7? So let's just do that. I'm really doing this. I'm really doing this. But as you can see, 28. Basically a continuous block of 28. Continuous block of memory. And when we did size of, it returned 28 bytes, which means that there are 28 bytes in this buffer on the stack. That's really it. So let's go ahead and use our buffer. How do we use our buffer? Well, it's the same thing as an array. So we could type in transactions buff, and then we can do 0, and then we can say 499. And that's really it. There's nothing else to it. So we have the first item, and let's go ahead and create more things. Now, it's 1 through 6, so 0, 0 through 6. There we go. So we have filled up all of our buffer with we filled up our buffer with data. So then what we do is buffers are basically like larger, and these are all packed together, by the way, compared to an array that is different. So this is 0 through 6, and I want to represent multiple different prices. Let's say this one is 10, and then I want to also add the F keyword for precision, and that's really it. So this is our buffer. And then we can also do, all right, well, here I want to say, I don't want to do the size of that, but let's do this manually. I'm gonna loop through this buffer. I'm just gonna do it the cheap way. So I'm gonna loop through 7 times I++, and then transactions buff I, just to get all of the elements that are in that buffer. And then let's say a hacker got in, and they're gonna set, after printing out everything, they want to set everything to $10 and ruin everyone's life. And then I'm also gonna print out all the stuff again. So this is before and after. And then I'm gonna show you a representation of it. So like this is gonna be before, and then here is gonna be after. So remember, buffers are packed together, arrays are different. Arrays are different. Arrays are just like lists. I'm not really good at the distinguishing between arrays and buffers, but just know that buffers are a continuous block of memory. All right, so we have the before and after. We run a program, and as you can see, it prints out all the prices, and then after it's just 10. So that's really it. So this is a buffer. And for buffers, we can do it with any type, any specific type. We can do a char buffer, int buffer, float buffer, double, bool buffer, if we want to, string buffer. We cannot do a buffer of arrays. I don't know why would you want to do that. You can't do that either. But that's really it. You can represent almost all or all available types or your own types. You can also do a buffer of structs. And a buffers of structs are basically, let's say I want to do game object struct, and here I want to do int value. I want that value here, or I want an ID. Now, if I create a buffer of this, well, depending on the size, it will say, okay, so the size of this should be just 4 bytes, but let's say int ID, let's say bool active, actually in scene. That will check if it's in scene, and largest to smallest, so this should be 5 bytes. That's if we get the size, but it adds padding at the end anyways. So if your struct is misaligned, your buffers will also be misaligned as well. But correct me if I'm wrong on that. So if I create this, then I can also create a game object buffer, and I can represent objects of that structure. So I can represent buffers of that structure. And then I can also do the same thing. I can create that structure. So I'm going to show you that right now. So let's create a game object. And I put s's here because we're setting that value here. And here I do something called list initialization. C++ allows you to construct that object in memory with the constructor when it's called, rather than setting the values. This is good practice. So we have ID, and then we have in scene, and then that's really it. Oops. Now, if a buffer was on the heap, then we would have to call the object's destructure after we were finished with the item in there, because it is a block of memory, but we have to clean up the object, so we have to create the destructor. That's if we casted this inside of there. All right. Actually, I'm just gonna do heap allocated buffers instead. All right, so there we go. We have our game object, and we're gonna go ahead and construct one into this buffer. And for just thoughts, I'm just gonna do two objects, and then it looks like our buffer, it's saying no default constructor exists. So I'm trying to figure out what's the issue when I'm trying to create a buffer on the stack. For here it worked, but here it just doesn't like me. So I'm wondering if it should be an array instead, but I'm doing something wrong. So that is my fault. But you can create buffers of structures too. That is also allowed. All right, let's continue. Now, the last one is heap allocated buffers, and these are on the heap. And the difference between stack memory and heap memory is that it's important to know these two things. In the stack, it's fast. It follows a rule called the last in, first out rule, where the last item that was on the stack is the recent item put out. Let's say I have a pantry or a fridge. The fridge is empty, and let's say we load our program into the fridge, and I put tomatoes, oranges, apples, and cereal. Now, the recent item that was entered in the stack exits there. So cereal is out, then tomatoes, then oranges, and then apples. So that's really how the last in, first out rule works. Basically, the most recent item that was entered in the stack is out. The stack is fast. It is very fast, and it is pretty good. You can't really have too much items on the stack. How would I mean this is that if I create an overly large array on the stack here with a absurd amount of size, it will cause something called the stack overflow. The stack size is configurable. It is around 4 megabytes to 9 megabytes, but I'm going to say either 8 or 9 megabytes. But the stack is configurable, and it has a size of, I'm going to say either 9 or 8 megabytes, but it's configurable. So that's the stack. The heap is different. There is no order for the heap. For the heap, it's not really your friend, and it depends on how much system memory you have on your computer. And if I go to my system memory, I have 32 gigabytes. And what's so important with the heap is that we manually control the memory that we allocate on the heap. And that's why us C++ programmers have to use delete or concepts in C++ that protect us from memory leaks when it comes to using heap memory. And also the stack isn't safe either. You can also do some things on the stack and get crashes as well. So understanding the difference between the stack and the heap is very good. So let's go ahead, let me stop yapping, and let me create a buffer for you guys. So a buffer on the heap is really, I wouldn't I wouldn't really call it a buffer, but let's say I were to create a int pointer, and then let's say my score list. But this time it's on the heap. And then I'm going to do new int 5, and there we go. We have, this is on the heap. Now let's go ahead and use our score list normally. So actually, hscore list. I'm not really good at variable naming rules, but it's cleaner if you do it like this, or you can do snake case. As long as it's readable, then yes. This is H score list, and this represents our score lists of scores that are just going to be put in system memory or whatever. So we have our buffer here, and I want to create a const size t. Uh, this is going to be 5, so we can use a for loop with that. And then we can use it as normally. So we can do H score list 0. And this is not good. Wait. Oh, yeah, like that. So H score list 0. And let's say our first score was just the same thing, 20. There we go. We're using this as normally as like an array. So 1, 40, and you basically know the gist. But here, we can't really do that size of thing with the array, because if we were to do that, then we were to get a crash. So let me just go ahead. Let's initialize some data, and I'm going to show you the better way of going through that, looping through a heap allocated buffer. And then I also have to tell you one important thing before we're pretty much done. Um, So we're gonna create this here. I'm gonna create that H score list. Um, H score list again, 3. Let's say we got a score of 90, and then H score list 4. Finally, you got a 100. Now, Now, for the arrays, we could have done, we can't really do size of H score list because that's the size of the pointer. And again, it's going to give you 8. And if you divide this by the size of int, it's going to fail. So instead, we're just going to use our buff size variable because we're manually tracking the heap allocated array size. So here, we're just going to do I++, and then since this is a size t, I'm going to do size t here. And we can also get the size of this as well. We can also get the size of buffers as well. So let's go ahead and do std cout. And then this is going to be the h score list. So we're just going to do h score list I. And we can use the pointers as normal, but I'm not really going to do that. So since this is a size t, we can't really I wouldn't say mix int with it. I'm just going to do it like the normal way. Now, once we're done, we can run this program, but before we do anything, we must delete this memory because we allocated with new. So if you use new, use delete. If you use malloc, you use free. But I'll track that in another video. We're not going to use malloc here. We're just going to use new and delete. So we deleted our memory. Once we're done, we released it back to the operating system. We run this, it loops through our heap allocated buffer that's on the heap, prints all the values, and then it deletes the memory once we're done. Now, here's a better way of doing this so we don't have to manually type delete down here. And it's going to save you so much things. First thing we're going to do is include memory because we're going to grab a smart pointer called unique pointer. And here, instead of just saying new, what we do is do std unique pointer int. And here we're going to do our score list, actually p score list, equals to std make unique int, and then this has to be an array, I forgot. And this is this too. And then new int 5. And std make, oops. Let's see, it says make unique, but it says that it's not really doing good. So let me see. I think it just wants int, but in here I can do new int 5, and then this does not need delete, and this is actually h score list back again. But the operand doesn't work anymore. That's because since this is still a pointer, pointers require the arrow syntax. So I think we're not supposed to dereference that, but let me see. What I'm going to do is I'm going to comment this code out. And then I'm also going to comment this code out because I'm rushing. All right, now I need to learn how to index this buffer here. So we stated new int 5. So I think first of all we can do h score list. This is a pointer, we don't really need to do arrow syntax. So let's say 0 equals 22. Let's test. Are we supposed to dereference this? No. This isn't allowed. So this is unique pointer, and it allows us to automatically delete the pointer when it's cleaned up. But it looks like I was mistaken with new and delete, and this is the syntax issue I'm facing. So I have to study myself, and I apologize for that. It looks like that I've made a simple mistake where I think it's supposed to be, this is like, this is the value here, but I want to represent an array, so. Okay, this should be the length here then. So if I was right, no way. There's no shot I got it right. This has to be wrong. Oh, I got it right. All right. Well, never mind. All right. So that's really it. This is a unique pointer, and as you can see, this cleans up the memory when it goes out of scope. So when it goes out of this scope, the memory is automatically freed and it is finished. So as you can see, I didn't have to do anything there at the end. All right, guys, I don't want the video to be too long, but that's really pretty much all of the basic data types in the C++ programming language. I hope you all had fun watching the video, watching me suffer and all of that. I went through buffers, we went through heap allocated buffers, we went through some distinctions. And I understand that this video is supposed to be about data types, but it's okay if you don't know all of these concepts yet, or the stack, heap, virtual memory, hardware, and all of that. Just know that these are pretty much all of the types that you need and you could use in the C++ programming language so you can represent data and you can create your programs with precision and you really don't have to worry about memory or anything like that. Just create C++ programs, and please expect things to crash. But I'm basically, I'm pretty much, I'm hoping that I given you the tools that you needed, the survival guide on how to use these types and play with them. Go ahead, open up the compiler, open up an IDE, and just play around with them. And if you have an error like me, like I always do a simple Google search and I go on forums or anything and use learncplus.com, which is better. And I don't recommend using Google searches because sometimes things are wrong. Let's say I want to do let's say I want to use write process memory. This is mostly wrong. Sometimes this is wrong. Sometimes this is right. So I would say, in my opinion, don't rely on this all the time. Don't rely on this popping up all the time. So, me personally, I don't really use this overview myself. I see this and it really does explain the concepts and things like that, but you get more if you read the documentation. But there are a lot of things you can do before you can write process memory because it is a process in Windows. But other than that, thank you everyone for watching this video, and I hope you guys had enough fun. Uh, if you have any questions, please ask them in the comment section. Maybe correct me if I'm wrong, but thank you for watching, and I'll see you guys in the next video.